Right, we're jumping into number patterns, so I think we should, of course, make it make it maths, number something. Okay, so number patterns we've got, and the number patterns that we're looking at for now are all going to be quadratic sequences. So does anything come to mind when you hear quadratic? Or maybe not, and maybe you can see that in general part coming up, and the quadratic's kind of the squared, x squared idea, or n squared in this case. So let's just jump straight in with an example here, or like half an example. So we got this pattern given to us: 7, 10, 15, 22, 31, 42. Okay, so normally, or not normally, but if you've seen a pattern before, I don't know, what types of things do you look for when you look in a pattern? I mean, there could be all sorts of things. Maybe square numbers jump out, or maybe it's the same number just repeated all the time, or maybe it goes up by the same amount all the time, or I don't know. So many things could come to mind here, and I don't know. For me, I often think, okay, well, let's just see. Maybe we're just doing the same thing all the time. You're just adding, so like 2, 4, 6, 8, 10, or let's see what happens here. So over here, we're gonna see. Well, 7 to 10, well, we're adding 3. 10 to 15, we're adding 5. I was going to keep going. 7, we're adding there. 22 to that, we're adding 9. 31 to 42, we're adding 11. Well, now it looks like another pattern's emerging. So, here we're looking at what the difference is, right, between these numbers. But wait a second, doesn't another pattern seem to be emerging here? Well, it looks like if we do this game again, well, from 3 to 5, we get to 2. Well, our difference is 2. 5 to 7, difference is 2. 7 to 9, 2. 9 to 11. So this difference over here is, well, it's constant all the time, right? 2, 2, 2, 2. But I can't have difference and difference. So let's say that this one here is, the first difference, and this one here is the second difference, right? It was the second one we did. And maybe something else that's interesting in a pattern is, well, where do you start? So maybe this part here can kind of go, well, this part here is our first term. Okay, so the second term, third term, fourth term. Okay, so there's some stuff, maybe you just take a little second and jot all those down if you haven't of, the first difference. And I don't know, maybe this one's exciting. Look at this. We had the first term, so let's look at this one here. This one here is like the first difference. There are too many firsts, right? So yeah, we've got the first difference, but the first difference was 3, and then our second difference, well, that was constant all the time. That looked like it was 2, 2, 2. Okay, let's jump abstract, or more general, I should say, now, and then we'll come back to this pattern over here. So in general, I'm just going to tell you that our general formula is going to be of the form an squared plus bn plus c. Now it looks like almost like a parabola type thing, right? We got n squareds, we got the squares, the quadratic. So if that's our general formula, and we're going to have to find out what a, b, and c are, well, let's just sub in our first 3 values, our first 3 terms, and see what happens. So when n is 1, to find our first term, which we're going to call t1, well, we're going to take this an squared, and we're going to go, well, we've got a, n is 1 squared, plus b, n is 1, plus c. So this is in general, this is going to be the first term. Well, 1 squared, 1 times a, well, that's just a. So we got a, b times 1, well, that's just b, c, well, c. Okay, so our first term is always going to be just a plus b plus c. So if we write this here, our first term is a, I'm just going to give a little bit more space here actually and go, well, we've got a plus b plus c. That would be our first term. Second term, well, we just substitute in, right? So go for it. We got a, n is 2, so we're seeing a 2. So whenever we see an n, we're replacing it with 2. Plus b, 2 plus c. And let's simplify that. 2 squared, 4. 4 times a, 4a. B times 2. Well, normally we'll just write that as 2b, right? Plus c. Okay, so our second term is 4a plus 2b plus c. Okay, and third term, same idea, go for it. So we got a times 3 squared plus b 3 plus c equals 3 squared 9, a times 9 we could write as 9a, b times 3, well, plus 3b, and c, well, it seems like c is just c all the time. So 9a plus 3b plus c. So in other words, that would be, and then we could keep doing this, but, well, if I moved that, my head right bit in the way. So, there are first three terms. A plus b, we can do this. Well, let's move on. A plus b plus c, that's our first term. 4a plus 2b plus c, second term. Third term, 9a plus 3b plus c. Nifty, hey? No. Okay, so there are first three terms, and let's do what we did before. So we had those things, and then we found out what our difference was. Well, first of all, we saw this was our first term. So this is the first term. And then we found out what the difference was. So what's the difference? In other words, what do we need to add to a plus b plus c? Let's do this. What do we need to add to a plus b plus c to get to 4a plus 2b plus c? Well, what do we need to add? And I think a useful way of looking at this is just do it variable by variable. What do we need to do to get from a to 4a? Well, we need to add 3a. What do we need to add to get from b to 2b? We need to add another b. What do we need to add to get from c to c? Well, nothing. Okay? And we could do the same thing here. So what do we need to add to get from 4a to 9a? Well, we just need to add 5a. What do we need to add to get from 2b to 3b? Well, we need to add a b. What do we need to add to get from c to c? Well, nothing. So here our first difference is 3a plus b and then 5a plus b, and so it would go on. And let's now go, what do we do next? Oh, we find our second difference. So from here we said, well, let's go from 3a plus b to 5a plus b. Okay, again, what do we need to add from 3a to 5a? Well, we need to add 2a. And from b to b, well, we don't have to add anything. And remember, this second difference is constant. So here, our second difference is 2a. So let's just pause. Let's sum up. What have we done in the last 8 minutes or so? Well, we've worked out that our second difference, let's just draw a nice line there. Our second difference is always equal to 2a. Remember, the second difference is the same all the time. So 2a, 2a. Our first difference, it seems to keep changing, right? 3a plus b, 5a plus b. But what's our first difference? Well, that's going to be 3a plus b. 3a plus b. And our first term, remember, that's just T1, is a plus b plus c. So those are three take-homes from our general. And we're going to use that in the example that we just had. So let's go back to our first example. Hopefully we can have that in shot. We need to find out what our general term is. So remember, we said that Tn is, well, we said it's an squared plus bn plus c. That's one of those, like, what's the general form of a straight line function? You're like, y equals mx plus c. So this is one we know. Tn is an squared plus bn plus c. Then we look back at what we had here. Well, we had 7, 10, 15, 22, etc. So 7, 10, 15. So this bit here we had was 7, 10, 15. Was it 22 after that? I think. Yeah. 7, 10, 15, 22. Then we started working out our first difference. So we're like, 7 to 10, that was 3, 5, 7, and so it went on. Then we said, well, let's work out what the second difference is. Well, the second difference, look, is always 2. And now we use our general form to go, well, what we worked out here is that the second difference is always 2a. So in other words, this bit over here is 2a. So if 2a equals 2, a equals 1. Cool. Then what we said was that our first difference was 3a plus b. This is something you're going to have to remember. So this bit over here is, what did we say it was again? 3a plus b. So for now, you're thinking 3a plus b, this is all brand new. But once you've done a few, you'll just kind of remember this. So therefore, we know that 3a plus b is 3. 3a plus b is always going to be that first difference. Now, we know that a is 1. So 3a is just 3. 3 plus b equals 3. Oh, well, in that case, b equals 0. Okay, cool. So then we've got our last bit, and that was our first term. Well, our first term, we said, well, the first term is always a plus b plus c. Again, something we're just going to remember. So we know that this bit here is a plus b plus c. So let's put this maybe over here. A plus b plus c is our first term, 7. Now we know that a is 1. We know that b is 0. So plus c equals 7. So 1 plus 0 plus c. Well, so 1 plus c equals 7. In other words, c is 6. So we've used these ideas of starting with 2a is the second difference, 3a plus b is our first difference, and a plus b plus c is our first term. So now we know our general form is Tn equals an squared plus bn plus c. Well, let's just neaten this up a little bit. 1n squared we normally write as n squared. 0n, well, not doing too much, plus 6. Okay, so there's how we do it. So let's run through one example together now, or not together, I guess, but sort of together. And we're given the following quadratic sequence. So determine Tn, 10th term, which term is equal to 80. So we run through our steps and we go, okay, well, this is probably going to be important. Our first term, T1, is 5. We worked out, last time we went for our first differences. So 5 to 12, what are we adding? Well, we're adding 7. 12 to 23, what are we adding? Looks like we're adding 11. 23 to 38, what are we adding? Looks like 15. And so we can go. But to be honest, I've told you it's a quadratic sequence, or we've been told that. So I'm not going to keep going and just say, well, if that's 19, that's great. But all we actually worried about is 5, 12, or 7 to 11, this is 4. This is 4, but we know that the second difference is going to be the same because it's a quadratic sequence. So now we go, okay, well, what we remember is that 2a equals our second difference. Okay, so that gets us in, a equals 2. Then what we remember is that 3a plus b. Remember, where am I getting all this from? Our first difference is always 3a plus b. So it's just something we remember. So we remember to go, okay, and I'm just scribbling all over the show, 3a plus b equals our first difference, equals 7. Now we have to have worked out what a is to find b. So a is 2. So 3a is 6. 6 plus b equals 7. Oh, well, b must be 1, right? 6 plus 1 is 7. And the last bit is that this first term, we always remember from this that we worked out, T1, our first term, is a plus b plus c. So now we can do it here. This is really organized, right? A plus b plus c. Try and do it in a more logical, or just, I don't know, a better visual, I guess. So a plus b plus c equals our first term. What is the first term again? Oh, it was 5. 5. A we know is 2, so that's 2. B is 1. 1 plus c, we don't know yet, we're trying to find, is 5. 2 plus 1, 3. Let's just capture this. 3 plus c equals 5. Oh, well, 3 plus 2 gives us 5. So therefore, what we've worked out is that Tn equals an squared plus bn plus c. Cool, there we go. That's part A answered. Of course, all the working was important, but there was our first bit. B, the 10th term. Well, we're just working out T10. So wherever we see an n, 10 squared plus there's an n, 10 plus 2. Okay, well, calculator out and you go 10 squared is 100, 200, 200 plus 10, 212. Okay, and as I say, punch in the calculator if you want. Now for our last one, which term is equal to 80? Well, for here we can go, well, Tn equals all of this. So Tn, in other words, we're almost working backwards. So we're saying the answer's 80, and we're trying to find out what n is. Which term gives us 20? So we need to work out n. So sometimes we feel like we're working backwards here. And from here, good old factorization and solving quadratics, which you've done in the first term, comes in handy. And we go, okay, well, we can rearrange 2n squared plus n plus 2, subtract 80 from each side of our equation. So if we subtract 80 from each side of our equation, we've got, well, let's just show that, I guess, minus 80. And the reason we do that is then it equals 0, and then we can factorize. So 2n squared plus n plus, well, wait a second, 2 minus 80, I think that gives us minus 78 equals 0, and we solve. So up to you. Do you want to factorize with brackets, or do you want to use the beloved quadratic formula? I'm going to use the quadratic formula just to remind us how it worked again. We had x equals minus b plus or minus the square root of b squared minus 4ac. Everything over 2a. Remember that formula, right? Handy one. Just because I don't feel like factorizing going, was it 2n 39 or I don't know. So now we just punch that in our calculator. It's nice to have this one in between step and go, well, 4 times 2, 8, 8 times 78. Calculator pops out. I've got mine here at the ready and I go, okay, well, 1 squared minus 4 times 2 times 78 gives us 625. That's not quite what I wanted. There we go, play nicely. 625 over 2 times 2 is 4. And so we can punch that in our calculator. Bracket here, minus 1 plus or minus the square root of 625. Everything over 4 equals n equals 6. Or, so that was if that was a plus. I'm going to change that to a minus. And we get minus 13 over 2. Okay, so we got 2 possible solutions. But wait, what does n represent? What are we trying to find? Well, this is which term is equal to 80. So it could either be the 6th term, t6 equals 80, or t minus 30. No, wait, that doesn't make any sense. Like, you can't have the minus term, you can't have negative terms, and you definitely can't have fractional terms. So, you know what, this solution over here was all well and good, but we're going to disregard it. So our final answer is our 6th term, n equals 6. In other words, the 6th term is 80. Okay, but here's our main heart of this. First difference, second difference, use our 2a equals the second difference, 3a plus b equals the first difference, a plus b plus c equals first term, and we take it from there. So there are a whole lot of nice examples to practice that are here. And so as you go along and practice, I think we'll get probably up to question 4 is a good place to stop before tomorrow head into another few questions. And these can get a bit more fun. Like, I'm really looking forward to getting into these ones. That's a good question, hey? So there are last few questions. And as always, you need to just make it make it maths. That's it, make it maths. I like that.